All right.
Hi, Yang. Can you hear me?
Yes, can hear you.
Your screen seems to be frozen for me. Sorry, my network.
Okay. Can you? But you hear me?
I can hear you, but your screen seems to be frozen.
Okay. Um, yeah, maybe my network is bad.
I don't know if your network or my network. Yeah.
It could be my network. It's frequently has issues.
Mm.
Maybe now it's better.
Yeah, I see moving, some moving, but yeah, now seems better. Yeah.
Okay. Were you there at the last meetup?
Last meeting? No, I wasn't. I was
Yeah,
traveling.
me neither.
I was traveling to see a football game, so I couldn't make it.
Okay. American football.
Yeah, American football. Yeah,
Nice.
it's a college
Who was
football.
playing?
It's a
Really
college
cool.
football. My college team, they playing the semifinal, but we
Oh,
lost.
oh no, that's too bad.
Hey Dan.
Hello.
And let's see. I feel like we did not have one last week. Is that right?
No, we
No.
don't have it last week. We had one 2 weeks ago.
Okay.
So yeah, this is bi-weekly now.
Yeah. Jan, I don't think you were able to join that one.
Yeah, no, I was sadly a bit sick at the beginning of the year, so yeah, but I tried to catch up on the discussion.
Yeah.
And
Hey, Talis.
Hey, Daniel. Hey, John. Hey, Steve.
And pin Eagle. Looks like my network is bad, I think.
yeah, actually now I also think so because my connections with the others seem to be better.
Yeah. I'm in a hotel, so network is bad.
You might want to try turning off your video because they don't have good upstream.
Okay.
That can kill you. Feel like we're missing a link to the doc that we've been using. So we have like the agenda doc in the meeting notice, but we don't have the other MV doc.
Oh, do you mean the
On
design
the-
doc?
John, do you have that one?
you mean where you added your
Yeah.
content? So on the 8th of January, there's a link to it, like from the in that summary. Yes, if you click on that, then you will get to the document. But maybe we could also highlight it somewhere else.
I can put it on the meeting notice too. And we should probably put it at the top of the agenda doc just so everybody can get to where they need to.
I put in the top of the. design thought.
See if I can.
Pint Eagle, he hasn't replied. So now 5 will probably can, I guess, get started.
I also added it to the meeting notice, so both of those are included. So we could probably consolidate these and just put the tabs for the agenda one in the other doc. We don't have multiple docs full of content.
You mean the freshness calculation tab as into the main doc?
Yeah, well, so we have 2 different docs. We have the agenda doc, which I think Stephen owns.
Yes.
And then we have the actual MV spec doc, which I believe
Yes.
you own, Jan.
Yes.
And we have 2 different tabs on that one. So we could just move the tab for the agenda one into your doc, Jan, and then we just have one doc.
Oh yeah, okay, makes sense.
So I might be able to do that because I think I have edit on all of these. And can I do that?
Yeah, look, we need to update the calendar invite with the doc link.
Yeah. So let's just try doing this. The agenda first. We'll paste this in here. I don't know that we had any comments or anything on there were like 2 comments that I lost. And okay, so maybe Stephen, we should just retire your doc, and I will go ahead and just update the meeting notice once again to remove that one from the. Okay, so we're good to go.
Okay, so I think for today, we probably can have 2 topics. One is to continue the discussion on the freshness from last meeting. There's 2 kind of semantic we're talking about. One is the freshness window starting from the last refresh, or and look forward, or from the now and look backwards, right? I think that's kind of 2 different approach was discussing last time.
Yeah, so this was the big point of discussion. I think it actually caused confusion for a couple of weeks there because I think Igor was thinking about it in terms of like the look back window from the client execution time. And I think a lot of the rest of us were looking at it from the refresh time forward as that window. And there is a subtle semantic difference between these 2 things. After we realized that we were talking about different things, which took a little bit of back and forth, I think we even kind of like came away from that meeting not sure if they were actually effectively the same, but I think Igor updated this with an example of like why the window approach is the look back window is slightly different than the refresh forward window. And that's highlighted in this little diagram here, where this query in particular, I think, is the one that we're talking about, where if you're doing a look back from the client perspective, even though the refresh happened at this point, let's see if I can draw. I can't draw. That's interesting. Even though, can you see my cursor on the screen?
No.
No.
Boy, well, that's unfortunate. I can't seem to do anything. I don't know why it doesn't let me draw.
Who is host?
Stephen is host.
I'm probably the host.
So, Steve, can you give the co-host to Daniel?
Let me see.
On the people section, you just click that Daniel's name and then say the co-host. You should be able to give the drawing things, I believe.
Let me figure out how to do that.
So while he's figuring that out, The idea behind this is that if you look at the top diagram, you have this box window. Oh, maybe you can see the cursor. Okay.
Now it works.
Okay, yeah. So this, you have the point of refresh, and then any query that runs within that, max staleness window would succeed because there is fresh data in the storage table. A query that happens outside of that, however, would fail because it's no longer considered fresh, assuming that you can't calculate that it's still fresh, right? So that's kind of the what is depicted here. And this purple means that like something changed in the state of one of the tables that's referenced by the materialized view, which is why this would be red. If this purple did not exist and you could calculate that the data feeding into the materialized view did not change, you could potentially still have a successful execution. But that's not what we're depicting. We're depicting here just what the staleness window allows, even with changes to external tables. This model is closer to the BigQuery model, or reflects how BigQuery looks at this apparently. And that is that you have this refresh time, and the window is based on when you execute a query looking back. So if I look back at, say, this first execution, like I actually have a refresh within that time. When we get to a later execution, like this, like we still have the refresh within the window, so we're still good even though there was a change that happened. When we get to this one, this is where the behaviors diverge. Igor, I'm explaining the differences between these two models. So I think this is what you were getting at. But the point here is when you execute this one, there's no longer a refresh within that time window, but there is a point at time where that was valid. So this period in time, like if we drew a line right here, that data was still valid within my staleness window. And that would mean that this query can still execute using whatever data preceded this change. It's only after that change gets out of this window that we start failing the query. So that's the difference between these two models. It's a little subtle, but I went through and I looked at a whole bunch of different implementations of materialized views. And I would actually say, first of all, staleness as a property is a bit of an outlier. BigQuery uses it. I think Dremio uses it or has some concept of it.
I also look at Redshift. They are from the AI summit. It looks like if they do automatic query rewrite, it's always strict. There's no, have to be fresh data. If you use a query the material view directly, it's always fresh. You mean they don't do any? You just consume it.
That's consistent with like the Postgres model, and a lot of models are either like you're required to refresh. Like it's always good. The Postgres model is the materialized view data is always good. If you reference the materialized view, it never considers staleness. Like you just get what's in the view, and a client is required to refresh that for you to get updated data. Full stop. There's no question beyond that. That's a very simple model. You know, it works for a lot of things. A number of engines, I think Snowflake, even Databricks to some extent, like they have a auto refresh thing, which is basically like poking that refresh from the behind the scenes. But even in those models, I think you're just consuming what's in the table. And so if like the refresh is taking a long time, or if it fails for some reason, you're still just getting the stale data until that refresh succeeds.
I would add that whatever poking behind the scenes Snowflake happens, it's best effort. There is no like marks or guarantees or none of that. Yep.
Yeah, I think that's the point. Like there's no guarantee provided about like when it will actually refresh. But the idea of staleness is more of a an engine implementation of how they refresh as opposed to a client side artifact of like when they can or cannot consume the data. They can always consume the data. There are engines, if you look through, I added these unfortunately like all in comments. I probably should have made a chart or something like that. But like StarRocks uses the model more like the first model. It's MV plus staleness based on my understanding of their documents. Sybase is another one that has a staleness. Again, like we're getting kind of esoteric here because there's not a lot that actually support this. So Sybase has it. That one looks like it's also the MV plus staleness. Trino also supports this, and it looks like Trino's model is also MV plus staleness. So we have, and it's not entirely clear to me. I could be wrong. I'm just reading the docs based on like the comments that they're providing. I didn't actually go and look at the implementation, but I'm pretty sure that Trino follows this model too. And so it's just kind of this question of like, well, we have one BigQuery that does the look back approach, and then we got a few others that do the look forward approach. But across the board for MV implementations, I think these are largely, outliers in terms of like the general thinking around MVs. Most of it is simple, just you can consume the data. When it gets refreshed, it will be updated. Otherwise, you just consume whatever was produced last refresh. So I think then the question is like, do we want to pick one of these models? Do we want to support both models? How do we want to deal with this staleness discrepancy between engines?
I would make a comment that the model that does the look back BigQuery approach is completely encompassing the other scenario. Like it makes freshness claims in all the cases where the first model makes freshness, and then an additional set of cases. So if we were to approach that, the algorithm that currently specs saying, hey, you just do simple lookup and you look at changes, that's still a valid argument. Like false positives are allowed in Max Staleness universe. So I think if we were to adopt one of them, I would feel strongly we should adopt the most encompassing definition, the most flexible. And then all the algorithms from a trivial one check to the complexity with a million stops in between, they all would be allowed.
There is a semantic difference between, and this diagram here shows that difference, right? Like they do not actually behave the same.
Right, but I'm saying the model at the bottom gives you a staleness answer, yes, it's consumable in strictly larger set of cases.
Yeah, and I think the way that I would think about it is more around like whose intent are we putting as the primary intent? Like the top model is the MV owner's intent, right? As an MV, I can tell you how long my data is good for, and you can't consume it after that. In this model, it's a client-side intent of, I want to be able to consume this data as long as it's, there's some data within this window. And I actually see those as distinctly different. I'm personally more in favor of the first model, though I'm not like strictly, bound to it only being that. I think that is more aligned with a definer of an MV controlling the validity of data, right? They get to control how long the data can be used.
Right. I disagree, but there's a raised hand. Let's Talat.
I also, after the meeting, I talked with the BigQuery's MV team, and they say that, but first of all, they say that Igor knows everything. I talked with the Matt, Igor, then
Say hi to him.
I asked them, what was the reason why we didn't go with the first, the option, and BigQuery choose the second option. They basically say that, and also makes sense to me, they want to decouple the refresh mechanism. And if you have so many MVs you want to manage, then the refresh getting a huge compute cost. But for the second approach, there is, definitely there could be a refresh cost, compute cost, but basically you have more window to use the data. And, that's why the BigQuery choose that. At least this is what they told me. In my view, I was in favor of the first option till Igor explained everything last meeting. Then after the meeting, I start thinking that, the whatever we are trying to achieve, like Benny suggests, or you and Daniel, you and me suggest that smart client, the dummy client. Actually, we were trying to model the second approach, there is a data, my query is not affected because of the data change, then how we can find the way. But the second approach is by nature, it's able to do that. Igor.
Rishab?
Oh, sorry.
Rishab, I think.
Hey, sorry. Yeah, I just joined the call. Sorry if this question is already answered or in before sync. So I was also thinking about this model, and there is another way to think about this is like instead of having max staleness, we can also have something like tolerance level, which client can set. And how that can work is like MV owner will be responsible for creating the MV, and from the client side, client can basically set a schedule for refreshing it and stuff like that, and can also set a max tolerance level. So what that basically means is like when customer or a client is trying to go and read that MV, and if MV is still like MV was last refreshed was greater than the tolerance level of the client, then client will get an exception, or otherwise client is able to read it. So that way, like different clients or of the same MVs can have different tolerance level, and based on that, they can try to read it or get an exception, something like that.
So that's kind of the do both approach, like look back, look forward, and they're two different properties. Jan?
Well, I think in the end, the clients can pretty much in the end always decide what they're going to do. So, and I think we're talking about what we will write in the spec and what we will want every query engine to agree on, or at least that every query engine gives the same guarantees. And I think I also think that in practice, having kind of this delayed view semantics, so the second part, is really valuable, because in some scenarios you can make it easier to refresh. On the other hand, I think we're not like thinking about kind of what do we document for our users, but we're kind of documented what for the engine implementers. And I think the first approach, so as Igor said, kind of the first approach is more conservative than the second one. So every case that is kind of valid in the first case is also valid in the second one. And since we want to define the spec in a way that's rather flexible to many different engine implementers, I would argue maybe for the first approach to write down in the spec that we want to have at least those guarantees, but similar to what we already were talking about, that every engine can have like additional checks. So I mean, an engine could still say, okay, we are following a delayed view semantics, because the iceberg, like this documentation isn't revealed to the user. In the end, the engine documentation will be what's kind of defined the user behavior. Igor?
So I have two comments. One is like respond to Daniel's comment about the producer mindset versus consumer mindset. I think I disagree there. I think in the second model, it's still a producer mindset, but we're not forcing producer to put a check mark saying, hey, refresh that point, it's still good enough. Like we're not forcing algorithm, we are forcing definition. That's why I look at that, but reasonable people can disagree.
Yeah, but you can't control, like as the producer, you really can't control how long the data can be consumed for, because that's actually more dependent upon the client's execution time and look back than it is defining the life cycle of the data that you're producing.
But we trust that model in every single cache implementation across every single database engine. Like they're saying, if I have cache and I have some kind of really complex key calculation and hash functions and blah, 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 and it can prove to customer data is equivalent, I'm free to service that cache. And I think that's exactly the same model here. If there is a policy saying the data is valid for n days, and I have complex lookup policies that says, hey, this is exactly equivalent, I'm free to service. I think that's the mindset of the approach here. But putting that aside, I think that's actually is not an argument I want to spend a lot of time on. I want to get back to your original thing. I think the discovery that I was a little bit surprised on, I don't think you were able to find a single engine that supports max stainless in the way we propose, and as in like if that policy violated, break the query.
No, there's 3 examples there. Sybase,
Okay.
Dremio, and Trino all support Model 1.
No. But do we fail a query if max stainless policy, whichever way we define it, is violated?
So they don't fail in that sense. What they do is they fall back to just executing the view definition.
So that's a part that seems like maybe we're a little bit misguided. Not a single engine fails a query in a kind of user visible way where there might be performance penalty. But in the spec, we're saying you must fail that query. That feels a little bit
No, we don't say that you
innovative.
must query. We say that you can't use the storage data. So you can still, like if it was Trino, they could still do exactly what they do today, and they could fall back to the view execution if they can execute the view. And like one of the big differences between having a vertical solution like, you know, BigQuery or Sybase or something like that, is that you have both the engine, the refresh logic, and the view definition and storage table, but we're decoupling those to some extent here. So we have to at least say that like, hey, you can't use the storage table, but that doesn't mean you can't produce incremental results. It doesn't mean that you can't execute the view definition. It just means you can't rely on the storage alone.
Sure. So let's go back to the subset of scenarios that we really care about the not sophisticated clients, dumb clients, whatever we want to call them. They wouldn't be able to do that, right?
No.
So they would have to, in that category of scenarios, we basically mandate in a fail.
Yep, exactly.
So that's a part that feels not consistent with precedent in the industry. That's the part that feels like every single engine said, how are we going to service our customers? Somebody says we're going to give them old data. Somebody says, no, we have really cute way to give them new data. Somebody says, oh, we're going to make them pay more and refresh the whole thing. Not a single engine says, here's a case of scenarios we're going to fail the customers, right? Not a single engineer made that call, and we are going to make that call for subset of cases.
But the important distinction is that it doesn't exist because all of those are vertical solutions, right? You don't have a scenario where it's like, hey, you can have a Python client that reads the underlying representation of a BigQuery materialized view. That doesn't exist anywhere. So yes, we are like paving new ground here in terms of like, what does this mean for clients that can consume the physical data, but don't really participate in view definition or refresh, right?
It still feels fundamentally broken user experience.
Talent.
Like in a way, like I was an engineer designing that feature set at some point. If I could sell that, oh, I would just fail query in that subset of scenarios, I could deliver it in a quarter of time.
But that's actually a larger problem than this question of like, how do we do the max staleness? Because at some point, regardless, you will be in a scenario where a client does not have fresh data. In either one of these, there is a point at which the data will not be fresh and the client has to fail, right? So that's a constant. Now we're just deciding, like, when does that failure happen and what are the criteria?
I thought you opening the box or door or whatever metaphor is right here, going back to should we define max staleness, given the fact that you found a huge diversity of implementations where it's not consistent and with variety of enforcement, I'm questioning if we actually added value here by strictly defining max staleness in the spec. And I thought that was your premise of your initial intro, that kind of I read between the lines, maybe incorrectly.
The reason for introducing it is to put bounds on how long the data is good. We could actually avoid this whole thing by just saying we're removing max staleness and we just treat it like Postgres, right? The data is good as long as it's good. If you want to invalidate it, you have to like drop the storage table or do something like that. If you want to refresh it, you have to call refresh. And that would be kind of
reasonable.
Yeah, I mean, like that is a reasonable approach. Like people use Postgres views, you know, materialized views all the time, and that's satisfying them. So the question is like, we could always just ask, do we want to support this max staleness construct? It does introduce these cliffs, like you mentioned, like at some point, like dumb clients are just going to like not be able to consume anymore. With that,
so my personal preference, this out of the way stack rank choices is not support, not define max staleness, because again, it's very diverse. It will create a ton of weird implementations. People will just try to catch up, and it will not really deliver value consistently. It will introduce those failure scenarios. the option number 2 would be the delayed view semantics, and option number 3 would be that's kind of my preference, but I'm sure I'm not speaking for majority.
I think Talit was actually next before we jump to Stephen. Talit.
Steven can go, then
No,
after
no,
that.
I think you're the next. Go ahead.
Okay. I was going to say the same thing. For Postgre, it's for a while open source project, and they choose the manual update because they know that they will not have a service running behind of the scenes, and the updating Materialized View very expensive. This is, I believe, a point for us, a decision. For Materialized View update, I don't believe even the single Spark cluster can update the huge Materialized View, and which means that in spec, either way, we can say that okay, there is no refresh mechanism. As long as it is created, it's always fresh, and you should define the the refresh mechanism. This can open the area for the service providers, and each of them can implement their own refresh mechanism. The Trino can do something else, Snowflake can do another things, BigQuery can also do different things. Or we can say, those, the one of the approaches. But when I look at as a service provider or catalog perspective, the second one is more reliable for the compute side, because then if I am a catalog, I don't need to refresh immediately all of the MVs after they are expired. And my queue is kind of less.
Stephen.
Yeah, I think I've been thinking about Yang's comment about in the end, we cannot control the engine behavior. For example, even we define the staleness. Let's say if the engine want to do automatic query rewrite, they want to enforce kind of the same result as you just query the view directly. So yeah, I think from that perspective, yeah, if we need define this max staleness.
Do we need to define a max staleness? This is the question, actually. Can we do like Postgres? Create your MV, and it's up to your refreshing. Sorry, Jan.
I mean, generally, like having some concept of this max staleness has some value, right? For many implementations, so that you can define. Or I mean, in the end, most of these implementations have a similar concept, independent of how it's defined in the end. But they have a similar concept, so I thought maybe it would be also valuable to also include this in the spec. And I would have a question for Igor. So again, we're not writing this for the users, right? We're writing this kind of for the engine implementers. And if we kind of define it similar as to we said before, we have like two checks, right? We have a time-based check if the data is fresh or if the storage table is checked, and we have a logical check if the data is fresh, right? And currently we're more talking about maybe a mixture between the two, but more about the time-based check. And in this definition so far in the document, it's stated that, okay, we have kind of this max staleness check at the beginning, and then if that fails, the engine is eligible to decide, like make any checks in the background and then decide on its own kind of whether to consider the storage table, like look at the view definition and decide whether it's still fresh and whatnot. And I think maybe the delayed view semantics falls into kind of in the same category. So in the spec, we only have to write kind of what we assume that every single implementation is doing. So we could, I also would actually prefer the delayed view semantic, because I think it solves a lot of implementation issues, but I think it's easier to enforce the first concept across all engines. And since like a query engine could still implement this delayed views, you wouldn't even need to tell your customers this is this max staleness property. You could call it differently and behind the scenes set the max staleness in a way that it conforms to the max views the semantics of the query engine.
Let me,
Does that make
so
sense?
that's the part that no, the last sentence, my interpretation was different. Let's say I build an engine that implements that whole thing that expires dynamic table much later, because I can figure out that no data has changed between the in a relevant window. If I do that, I'm not spec compliant, am I? That's the part that worries me. I think that's my interpretation. If specs says you have to implement this algorithm, I either implement it or I don't. And I
But
think
why
that's
does
the
it?
part.
Why does it break the spec when the spec says that if the refresh happens in the time since inside the max staleness window, but I could still consider it fresh if other criteria hold. This, like, if it's written like this in the spec, you're kind of free to decide on the query on the engine side. You're kind of allowed to make this decision.
Sure. If we define that other criteria, I think that if you think about what that other criteria would be, it would be something equivalent, like saying, hey, you can use all the data. If you're sure it's equivalent, valid, you will have to come up with some kind of adjective there. Yeah, I think that basically different way to express the same definition as delayed view semantics. I'm not married to particular words. I think we can rephrase it any way we want. But also I would like to have a spec that defines the criteria, not the algorithm, not the implementation. It feels wrong to say, hey, here's the code you need to write.
Mm-hmm.
So, but yeah, if we extend this thing, I would remove most of my objections again. Yeah, go ahead. Who's next?
Yeah, if I understand you correctly, you're saying in the spec, we can spec you are minimally required to do the top option, but you can also implement the second the bottom option, right? You're saying.
Yeah. And there's a million options in between. Like actually, you can probably push bottom options even farther. You can say, if there are changes, you can prove they're equivalently add and remove rows, and there is something old that you can use, and you can 100% sure. That actually strictly follows the delayed view semantics equivalency. You can even do that if you're very passionate about that optimization.
Yeah, basically the bottom option is just more permissive. So you can do a little bit more restricted, but you can also do a little more permissive.
And not again, if somebody wants to write that, I think it should be one of the suggested simple implementation. Like if you want to write option number 1, it should be here's code sample. Steal it, go ahead. It's compliant, it's good. It's not the most optimal thing ever. Nothing almost ever is, right? But that's a reasonable approach. Yeah. How many people in the room feel passionate that we should include max staleness in a spec? I know Jan is like, do we speak up in order? What's the decision here? Like,
I've been somewhat torn because I realize the complexity of this, and it seems real simple to fall back to the Postgres model, and that's easy to implement. I'm not convinced that you actually need the staleness guarantee. And with engines like Trino or something that already supports refresh or async refresh on access or incremental refresh, accessing through those would probably just end up refreshing it anyway. So I think it's a good question to ask. From a spec perspective, it's not like super complicated to add this one property, but then it adds a lot of complexity for implementers, right?
Exactly. Like the cost for implementers, the people who, and I feel a little bit sorry for engineers who will be estimating the thing. Oh, max staleness, it's got to be easy. 2 weeks, I'll be done.
So,
not 2 weeks, right?
One alternative is there were a couple implementations that don't support max staleness, but what they do actually do is expose a staleness field, right? So your consumer can query how stale is the snapshot or the storage table, and then the client gets to decide whether they want to consume it or not. And so you could run your query or qualify your query with something that says, well, if it's older than 2 hours, don't consume it. But then it's on the client to do those checks as opposed to the person creating the materialized view defining the life cycle of the data. And so I get the arguments for both. Simplicity wise, we should just do Postgres. Do we think that there's enough use cases out there, enough implementations that follow one of these other patterns that we should codify it in the spec? Jan.
I have to. So I also have. I didn't include max staleness at the beginning in the spec, but then I got many comments. Why wouldn't we add this? So I thought, okay, it would be valuable addition. And now I'm thinking, since many query engines actually have a similar property. So BigQuery has one, Trino has one, dynamic tables have something, and I think if we wouldn't specify a max staleness in the spec, everyone would still kind of fall back to kind of their current implementation, but everyone would kind of use a different semantics. And I thought kind of the point of the Materialized View spec is kind of to get a more consistent behavior across different engines. And since many engines use this concept anyway, maybe it would, like, I thought maybe it would be better if we had at least some guarantees that are compatible across all engines. And yeah, I don't know, Igor, if you have a direct reference, or I don't know.
No, Stephen was first, and then Talat, and then I'll say something.
Right.
So, yeah, I think Daniel mentioned about some system exposed that how stale the data is and left to the reader to interpret. I think for that we have the same problem, because how we compute how stale the data is also have these two options, right? As this diagram was describing.
Oh no, you're just basically surfacing the time that the refresh happened in some career way, right?
So you get the top option basically for that one.
Yeah, there's no properties or anything to set. It's just like, how old is that last snapshot, which we technically already have the information for. It's the time that the snapshot was produced, right? So it's already there. It would just be, how do implementers expose that in a way that a client can use? That was the comment.
Okay. All right.
Talent.
My understanding for engines, they use the staleness as a configuration parameter. Even though it's part of the MV's spec or property, like BigQuery use on the query time, it just get to that information and decide that the look back window, or for Trino, it's just using how frequently it will refresh from the refresher thread. I believe we can put the staleness property in the MV's definition. Then when the user create a MV, they can define that, hey, I want 1 hour data staleness. But the per engine, the behavior may different. And also, previously, as I said, that, we can start with the Postgres behavior. Data is always fresh, but there is a staleness configuration. If your engine support the refresh mechanism, then it can evaluate. And these are the two possibilities for the staleness. Like we can give as a guidance for the implementers, but at least on the baseline, we can say that MV is always refresh if you are not refreshing, and you can keep using that. Responsibility is on refresher. This can be a user by calling refresh MV, or this can be a separate service just looking to staleness and implement one of the algorithms.
I want to respond to Jan. So I think observations that a lot of providers have max staleness. I think a lot of providers have max staleness syntactical term. The actual semantic meaning is very, very different. For example, BigQuery, going back to BigQuery, we actually have another parameter called max refreshers per unit of time, something like that. I forget the exact name. But
there is two parameters. One is that interval for the MVs. The another one is the staleness for query itself.
Right, exactly. So one controls refresh cycle and kind of gives customer cost control, and the other one controls staleness.
Yes, on the query side. And also user able to overwrite that staleness window in the query time if they want to look back more the time for that.
Oh, cool. Okay, so that's another concept, right? Like given customer on the client side control saying either to catch up or willing to take more time. Snowflake staleness is very different altogether. There is only one parameter. It's basically a scheduling hint, no claims about query time behavior. And I understand all the other ones, we have their own flavors. Like the term max staleness is popular, but semantic meaning is, I think every single provider implemented something uniquely theirs.
I mean, my point wasn't that all have the same definition. My point was that everyone is using a similar definition, but only Postgres is kind of not using any max staleness definition.
Mhm.
And since
There's
many,
a bunch of them that don't define any max staleness, right?
yeah, okay,
Snowflake doesn't define one. Oracle doesn't define one. Databricks doesn't define one. Yeah, and I think DB2, like, well, they have materialized tables, which is like a slightly different thing. So there's a whole bunch that don't even touch on max staleness, and it's more a combination of Postgres model with some sort of refresh thing. Postgres doesn't even include the refresh, right? They're the lowest common denominator, which is just, it is what it is, right?
So I don't know where other people in the code. Did other people have any comments on this max staleness? We haven't speak before. Okay.
one question about Snowflake, but don't you have something similar, like something, or maybe it's not called max staleness, but
Target log.
it is. Yeah, target log, exactly.
It's an engine.
So target log is a really, I don't know if it's not a sophisticated scheduling hint. What target log does is says, hey, I would like to have my data refreshed every X minutes. We guess that refresh should take 20% of that time. We're going to schedule a refresh at every strict interval of X times 0.8. That's what target log is. That's all. Then there are really limited materialized views that are always fresh for on Snowflake side, but that's not an interesting feature. I think we're talking about dynamic tables, zero max staleness concept. It's just a scheduling cost control hint.
And
Okay.
and I think that's consistent with like the engines that support some sort of background refresh option. They span a range of like that kind of control where it's just like a hint to like, hey, this is a frequency or when I would like to have the data updated, and then it tries to figure out when is the best time to start that.
Right.
There are other ones that will do it based on base table updates. There are other ones that guarantee that you won't consume without the base table update. Like, so there's this spectrum of how do we hint the engine about when it needs to execute a refresh, but that's kind of outside of what we're doing with the spec. Like, you can configure all those things via the implementation of this. So all we're trying to do is present, you know, a consistent surface of like, this is how you define this thing, and then any of those like refresh mechanisms are left to the implementer.
I think actually that's a good way to think about it. Sorry, go ahead.
I just wanted to say that maybe we should ask Benny if I'm not sure, like, if he has an opinion about this.
If I remember from the past conversation, Benny seemed to be okay with not defining max staleness.
Okay.
Yeah.
Yeah, it looks like Dremio doesn't do any like freshness checks. They just look at the MB access time. It says checks at MB. It enforce the time-based checks at MB access time is what his comment was. So I think that's just kind of the max staleness check, which I think is what Dremio does as well. I'm not sure about that.
How the room feel about, you know, the having not fresh mechanism, like not for staleness on the spec, just defining the max allow staleness time as a configuration, as you know, in the spec.
I don't think that we want to have it without having a clear definition of what it means, right? So like we shouldn't just introduce the property and say, hey, it's entirely up to you what you want to do with this property.
No, we can also give the details about how you can use that property. Like the first option and second option is the how you can use the property. This is the property, but we are not in that business.
Okay, so I think what Jan and Igor were agreeing on before was like, if we spec out as a minimum the first option, but we use loose enough language that you can implement the second option from a client or execution standpoint, that would be sufficient to cover like all of these cases.
Okay, this is also makes sense.
I think we have to just make sure that we're clear on what that language is, because it also creates this dynamic of like, in one case you can consume from the storage table, in another case you can't. Like you're saying you can consume from the storage table when the first case might say you can't. So we have to figure out what is the language that allows for this.
Do you think that can we write that language now?
I think it would probably just be a combination of saying like, writing it in the sense that like you can consume the data in option 1 up to that window, but not explicitly saying you cannot consume it after that window, because that would leave enough room for the second one to say implementations may consume it after if, whatever. So I think we'd have to sit down and wordsmith what that language looks like. I don't think we can do it live here.
Let's update now. Then it's just getting time to remember the things, and we just revamp the conversation again and again. That's why I'm saying that.
So sorry, I jump in before other raise their hand. I think I'm fine with it actually if it's the option 1. So kind of like when we do the time-based check, but saying if that one is fail, you can still do the logic check, right? It's not saying if that one fail, that you have to fail. That's kind of the same philosophy along with that line.
Sure, yeah.
And you could still represent the Postgres model if you set it to if max staleness is none. You could like also the other use cases could like if it's not set, then it would just be the Postgres model.
No, but you're forcing clients to do something basic. You're forcing clients at least read the parameter and do some trivial basic implementation, right? And we're questioning, is there a value in forcing clients to do that? I think one point that Daniel made is, hey, there's a ton of things you can do on publisher side, on producer side, sorry, you can ton of things to do consumer side. The question we're answering here is there a common set that we should document? I think the question that Daniel put a focus on, is there interface between those two that needs to be documented? And that's what we question, because there is such a rich variety of max staleness producers' behavior and consumers' behavior. Question is, do we need to like force them in the same room, talk to each other, using max staleness parameter, using certain interpretation? Is there a value in that? And I don't hear consensus in the room that the answer is yes. I think we're like 50-50 right now. I'm guessing. I don't know.
Shahir.
Okay. So from my point of view, option 2 is kind of a more optimized version of option 1. There are extra overhead you're putting for if you implement option 1. So I don't think the benefit that we get from option 2 is that much that explain adding it as a case. So
actually, it's huge. For BigQuery, it was a release stopper. A lot of people refresh at random times, and if you cannot recognize that loose refresh behavior, the difference is huge. But the point is, option 2 doesn't make option 1 calculation valid. It's still fine. Like you can implement option 1, you'll have some false positives. It's great, spec compliant, you can do whatever you want.
So what if we just allow the client to choose between option 1 and option 2 and keep both?
Yeah, I think we should pick the most permissive definition. That would be option 2, and allow client to stop anywhere in between, including option 1, option 1 plus plus, option 1 minus minus, whatever. Yeah, I think that's what we're going to. Like it should be the most permissive, and then client can do anything in between. If you're not convinced it's fresh, you can fail a query and say it's like, I'm not sure, I'm not sophisticated, I don't know if it's fresh, I should fail. False positives are okay on the freshness calculation.
Okay.
Should we spill out to, the for implementer, should we say that, hey, you should have a refresh command on your engine? We are talking about the staleness and those things, but there should be mechanism either way, option 1 or option 2 or option 0, which is Postgres approach. There should be a mechanism to, to call this refresh for the MVs.
No. No, that I'm very concerned about that. Like,
Okay.
mostly because now we're defining how do you poke some engine to do a refresh operation, and that's complicated. I don't even think that depending on where you are, you would necessarily have access to invoke that thing. And speccing out how you would make that call would be incredibly complicated, right?
No, I mean, not the call, but at least the basic, like, you should have a tool to refresh.
I don't think that's necessary from the spec perspective.
I see.
Right. I think most cases are going to be like one of these managed engines that you just have like something you configure within the engine that's going to keep it refreshed, right? You're not going to have like multiple. And if you got a client that's like a Python client, how does like it can't refresh itself? And now you're saying, well, we want to put something in that would tell it how to invoke the refresh. Well, what does that look like? Like, do I need my JDBC connection string to Snowflake and the command to execute? And I think that's going.
Yeah. Sorry, my bad. I was thinking about the Spark implementation. You know, that's why I just think that maybe we should put that. Okay, sorry, I take back.
Okay.
So how do we reach a decision on whether to include the max staleness or not?
I think we should start with what Jan and Igor suggested, which is get some wording down and see if we think that that's compatible and reasonable with option 1 and option 2 to kind of like define max staleness in terms of number 1 and allow for number 2. It's possible that we sit down and we do that wording and it ends up being garbage and like we're just, we're making a mess of the spec to be too permissive. And I don't know, I guess I'm conflicted here because it's almost to the point where like, I actually don't like option 2. I understand the value of option 2, but I think it also gives the least amount of control. So I think my fallback scenario would be go to the Postgres model and avoid this whole thing.
The thing is, if we don't define max staleness at all, it's also kind of hard to talk about freshness, right? Or we would need to, like, you can't say it's so without max staleness we don't have this time-based freshness. We only maybe have kind of this logic-based freshness that if kind of you execute the view and you get the same result, then it's your storage table is considered fresh. Or we just say it's up to the clients to decide. And or generally you would need to say kind of freshness is some concept of the client, like since we're not like really defining it in the spec.
I don't think we need to define freshness. I think we just need to define last refresh time. And freshness, keep it completely open, but whatever it means. Maybe your freshness is different on Tuesdays and on Wednesdays, and that's your business, right?
But it makes like in the spec you talk about like freshness is kind of a central concept in materialized views, and if you I think the term fresh or not, it appears throughout the MV spec, and if you don't really have a wording for that, it kind of makes it difficult. Or I think the spec is going to read really weird, where every time you kind of try to say something to avoid being too specific. Right?
Does freshness appear anywhere outside of max staleness references?
It's not in the Postgres docs. Like I don't think freshness shows up at all because they don't really have a concept for that, right? It's just you have your materialized data, and you can refresh that. So I think what we want to do is let's start off with the wording. Let's see if we can define this in a way that we can agree on. And if that is too loose or too messy, then we need to figure out, do we want to go for option 2 or option 1? I am a little concerned that option 2 may put an additional burden on implementers that don't support option 2. Though we may be able to define what the calculation looks like to provide an easy solution. Because like what Dremio's comment was like, hey, they don't do any of the calculations because they think those checks are too hard. Maybe they're not. But let's start with the first option that was proposed, which is let's try and get wording that accommodates this.
Okay. Jan, you want to take a pass on that?
Yeah, I can.
Or
Or
do you want me to?
yes, I can. formulate something and I'll write it on the mailing list.
Mhm.
Or
Yeah,
if I mean, you can also go for it. If
I'll
yeah,
try
or
to do
maybe
my-
it actually might make more sense if you write the wording, since I think you're kind of the
Right.
most experienced
It
in this
just-
space.
The way Daniel phrased the problem, I might have compromising incentives. Daniel says if something we come up with is going to be messy and unreadable, we fall back to Postgres model. And I feel conflicted. Maybe I should write something really, really messy and unreadable. But Daniel, going back to your comment and saying, hey, you worried about option 2 forcing client something. It's not about forcing, right? Like, why are you worried about forcing? Saying, hey, that's the sky's the limit kind of model. You don't have to fix it. Most of the reach it, sorry. Most of the industry doesn't.
Well, I think if we define the spec in a way that option 2 must be done, right? Like that was the comment that like you must follow option 2.
Oh,
Yeah.
no, you
That's what I'm saying is like I don't think we want that. So
right.
go with what we said. Let's see if we can define in terms of 1 that allows for 2, and see if that makes sense from a spec. Like just the wording, if it's clear, if it just leaves too much ambiguity, if it looks confusing to implement. I think it probably can be done, especially if we aren't saying explicit things about when you must not consume from the storage table, as opposed to just saying it is considered fresh when, right?
Yeah, I think kind of like the time-based is the simplest one. We say everyone required to do it, but you can do additional check, like logic check. Same thing. If option 1, you find that it's there, you can do additional, more relaxed, more permissive check. It's kind of optional. You can go there.
Unfortunately, I have a hard stop, so I have to drop here.
All right. Thank you, everyone.
Can we schedule closest time, rather than waiting to 2 weeks, Steve?
Sure, I can schedule one next week, I guess.
Okay, at least then we can be fresh. Then we can.
Or we can continue on the mailing list maybe with this discussion
Mhm.
to
Sounds
be
good.
quicker.
Okay.
All right. Thank you, everybody.
Thank you.
I don't think that. I actually have to. Okay. Yeah. Yeah, no, I saw it. The one that is looking fools on. So, yeah. That's what I thought. Fuera de tenía cualquier tiempo. It's our fault. Yeah. That's I don't know, just convert. Yeah. I, you know, so, you know, sort of, um, it's a pretty good place. So, it's the demo for that, and it's just never, what's the word? That's sort of. Not those over apps for them. All part of it. Just because they don't think there's, and rather, right now they're already linked now. But I'm going to.